In this video, we're going to discuss the parts of an energy diagram. But before I dive into the different parts of an energy diagram, there's two key words you need to know. The first word is reactants. When we talk about chemical reactions and the many different types of chemical reactions out there, the beginning part of a chemical reaction starts with reactants. And then we have the end part, and that's our products. So let's use the example of baking a cookie. When you go to bake a cookie, you get out all your different ingredients, your flour, your sugar, your butter, your eggs, and so on. Those are your ingredients. Those are your reactants, your starting point. Then you end with a baked cookie. That's your product. That's what you end with. So same with a chemical reaction. You start with reactants, you end with products. Well, an energy diagram is a graph. And on your graph, you have your y-axis, and that's your potential energy, and then you have your x-axis, and that's your reaction coordinate. And there's two versions of an energy diagram that you'll see. Version 1, it starts up high, goes up, and then goes down. Version 2 starts low, goes up, and then stays pretty high. Well, when we're talking about an energy diagram, we need to place our reactants on our energy diagram, and they go on the left-hand side here. Then we have this stage in a chemical reaction, and we call this our transition state. It's this middle ground between reactants and products. So let's go back to that cookie example. Well, when you have all your different ingredients, you mix them up and you put them in the oven, you don't magically get a baked cookie at the end. No, your ingredients, they start to get all gooey and then they start to harden up bit by bit, and then you get your baked cookie. There's this progression that takes place to get your baked cookie. So from going from ingredients to baked cookie. Well, same with a chemical reaction. You start with reactants, you get to this middle ground, this transition state between the reactants and products, and then you get your products, which go at the end of an energy diagram. So they go at the end here. Then you have what we call this activation energy. The activation energy is the energy needed for a reaction to occur. So you need a specific amount of energy for a reaction to occur. If you don't have enough energy, the reaction will not occur. So think back to that cookie. If you take all of your ingredients and you go ahead and you put them in your oven, if you do not start your oven, if you don't start it, those cookies will never become cookies. You'll have just ingredients. You need heat to be able to bake those ingredients to get cookies. Same here. You need energy and enough energy for reactants to become products. Well, the next thing we see this difference. Reactants have more energy than products in this energy diagram or this version. That means that energy is being released, delta H is negative, and this is an exothermic reaction taking place. So this energy diagram is an example of an exothermic reaction. Whereas over here we see that the reactants have less energy than the products. That means that energy has to be absorbed in this case. And the delta H is positive, so this is an endothermic reaction.